So this is our chance to go into a little bit more detail about the two tires that you'll be driving, the Empress S, the Touring All Season, and the Infer Sport, the UHP Summer tire. So a few things about these tires when you go out there. The all-season tire, the Touring all-season tire, you know, this is, the track is not its natural habitat. You can quickly, in fact, this is a good chance for you to compare what a summer tire feels like to an all-season tire. There's a lot more compliance, a lot more movement. This summer tire has a lot more grip, and is just oriented towards dry. Obviously, the all-season tire has to do a lot more than a summer tire. So that's one of the things you can look at. But when you're out there on this tire, it's not going to be about max lateral Gs. It's going to be about feeling the steering, kind of the comfort levels, the noise levels. In fact, if your car, if your Tesla is shooting the air conditioning on you, take a moment to figure out how to reduce the air conditioning so you can hear the tire, because it's pretty hot out there. If you press the temperature, if you've never driven a Tesla before, it's quite a learning experience. Just to start the Tesla, you need to know what you're doing, but they'll show you that. If you hit the temperature screen where it says the temperature in the car, you can turn the fan down so you can hear the tire as you go around the track. Okay, let's move on. Going backwards. So as I mentioned yesterday, we'll start with the Emfer Sport. This was a tire really developed for OE, particularly European premium sedans like Porsche, Audi, BMW, Mini Cooper. And it's OE on these vehicles. Some of the features here, I already covered the warranty last night. But summer tires traditionally have higher block stiffness. They don't need all those biting edges for snow, and they have very wide longitudinal channels to channel water. Wider than you would see on a North American all-season tire, because these tires have to function and live in Europe and in Germany where you have Autobahns, very high speeds, and it's not always dry. So these wide channels are able to move water even at 100 miles an hour on the Autobahn. This tire, hold on. I'll explain now the differences between the outgoing tire, which is the SU1 tire, and the new Emfer Sport, which is actually called the SU2 if you look closely on the sidewall. So the tread width measured from shoulder to shoulder is about 5% wider, and we've added that onto the shoulders themselves. So these shoulders are a little wider, a little bit stiffer than the previous tire. It's going to give you better handling and better stopping distance. The tread compound itself is also new. It's oriented for more wet grip. There's 28% more silica in the tire, and we're also using new polymers. So we're changing from what we call an emulsion type to a solution type. It just means better mixing and more precise polymerization in that compound. Also means increased tensile strength, which can translate to better wear. There's also more styrene in this compound. Styrene is the stuff that gives the tire grip in the wet and the dry. If you put a lot of styrene in, you get like a racing tire. You can stick your fingernail into the tire, and when you pull it out, you can still see the imprint. That's like a racing tire. That means you got a lot of grip. Yeah, John, you got a question?
Yeah, is the Emfer Sport the highest speed rated tire that you make for consumers?
It is for the road, yes. Now we have a Sport R, which I believe is currently not in production, that can be ordered. And that's a track day specific tire, but generally the speed ratings are similar to the Emfer Sport. So the other thing about styrene though is it's not great for rolling resistance. When you push your fingernail in and you pull it out, if you still see your fingernail mark, that means that compound's absorbed the energy from your fingernail and it didn't return it. It didn't bounce back. Think of a bouncy ball. You know, you stick your finger down into a bouncy ball, that it disappears quickly. That means it's returning all the energy to you, so that's a better rolling resistance tire. So we have to modulate the amount of styrene, the amount of grip in the tire, and balance it with the amount of rolling resistance. Okay, changing gears over to the N-Pris S. This is a tire designed for comfort, longer tread life, and improved wet grip, mainly. The tire is also capable in light snow. So this tire can function anywhere where you're not getting winter snow warnings on a regular basis. I'm going to go into detail on this in a little bit, so we'll save that technology. This is also slightly wider tire than the outgoing AH8, so that's good for stopping distance. Like all of our tires and all of our competitive tires as well, this is not particularly unique. We do very sophisticated noise treatments on these tires, so we're varying the size of each element so that we don't get any harmonics or any tonal noise in the tire. And that's all run through computer simulations and moving towards using AI as well. And then this tire utilizes 3D sipes. So the sipes are interlocking if you were to take a cut through the block, which means they self-support themselves and give the tire more block stiffness, which means in turn we can actually add more biting edges and achieve the same level of block stiffness. So that means, you know, in these molds, these sipes are little metal blades, and each metal blade is either 3D printed or stamped with contours and shapes in it so that it interlocks. Molds for tires are the most expensive part of I suppose, the equipment used to make the tire. Each mold is $15,000 to make these molds, and we have probably 4 molds per tire size so that we can keep the volume up in the production factory. Okay, the N-Pris S is going to be replacing eventually 3 tires, and it kind of takes the best attributes of all these 3. So the AH8, the AH7, which was our long wearing touring tire, and the Roadian GTX, which was designed for CUVs and SUVs. So eventually this tire is going to have 94 sizes, covering everything from 15-inch small compact sedans all the way up to full-size SUVs and CUVs. So 14 to 22-inch size lineup. It's a very quiet tire, which you'll hear out on the track. Improved, particularly in wet and dry, and capable of light snow. And this tire is also our first EV-compatible tire. So Nexen's strategy here is, everyone's trying to find their strategy in the tire industry. Hankook has gone all in with an EV-specific tire range. This is an EV-compatible tire, which means it's fine for standard gas vehicles, and it's also suitable for EVs. We've taken that into consideration when we designed it. So it's suitable for everything from Toyota Prius and Teslas through standard gas and hybrid CUVs and SUVs and full EVs. So anywhere you see a star here, that means this tire is actually OE. This is our next generation OE tire, and these tires are just coming out on these vehicles this year and next year. So a little bit about rubber compound technology that's going into the N-Pris S. It's similar to the Four Season 2. It's a high resin compound, but it's also using new polymers. And you may have seen this 4D compound. Someone was asking me about this yesterday. What's the 4D compound? It's a little bit hard to explain, but basically the best rubber compound is one that mixes well and cross-links well. So in a rubber compound, you have polymers that are generating grip, and you have fillers that are reinforcing that rubber compound to give it the stiffness it needs. And those polymers and fillers, they're cross-linking at a molecular level. And we're always trying to improve the efficiency of that process and to improve the number of cross-links in that process. So if these big balls are polymers, they need to be able to cross-link with the fillers. And so a functionalized polymer means it's basically got parking spots, it's got nodes where those cross-links can form in the compound. So there's a lot of chemistry and molecular biology that's going on to improve the performance of our tread compounds. And that's what the 4D compound means. Another area where we try to improve our compounds is in the temperature sensitivity of the stiffness. So what you really want in an all-season tire is for that compound to stay flexible at cold temperatures. So naturally, rubber gets hard at cold temperatures, which means your tire's going to have less grip. So if we can adjust the ingredients of that compound to improve the flexibility at low temperatures, that's called the glass transition temperature, TG. That's going to improve our snow performance. And then of course we want to maintain the stiffness at high temperatures. You don't want it getting too soft, otherwise your car's going to start, your steering response is going to drop, and your grip levels are going to drop at high temperatures, which is not what you want. So we're trying to flatten that curve with our compound technology. All right, we're moving along here. I'm just flooding you with technical information. This is not technical. This is purely design style here. They're quite proud of the sidewall design. It conveys kind of a sophisticated, high technology tire. It's a digital pixel design, they call it. So they're trying to tie in that kind of EV design language with the more traditional gas powertrains. All right, treadwear. This test result shows that we have a 14% improvement over the outgoing AHA tire, and same level as the Continental Pure Contact. This was validated through 2 tests, both our indoor wear testing on a drum in our YP plant, and then at Texas Test Fleet down in Texas, where most of the industry does their testing. And here's a spider chart of all the performance. So the main thing to look at here is this red line here is the performance of the Impress versus the AHA, the outgoing tire, which is at 100%. So you can see with these new technologies, new compounds, we've been able to expand that performance envelope in all directions, which is what we needed to do to keep up with the competition. As you can see, we've basically matched, exceeded in some places lower than the competitor tire here, which for legal reasons we're not putting on the screen. But bringing this tire up to a tier 1 level where the AHA was starting to fall behind. Yeah, John?
Being the best in everything is not really your goal, is it?
No, especially not on a tire like this. We want balanced performance in all areas. And, is treadwear up here? Treadwear is not up here, and yet that's probably the most important thing to the consumer. So we could expand this even more if we wanted to give up treadwear. We don't want to do that. We just want balanced performance for the consumer, for the everyday driver on this tire. Okay, now we're going to get into the AI portion of this presentation. AI is a hot topic, and perhaps you have these questions in your mind when you see this on the sidewall. This is one of our test tires, Impress S tires. What does the AI mean? What's VI? I read a press release about Nexen's XAI technology. What is that? Is this tire self-aware? Is it going to take my job? All this means is we are using AI-based tools, which I'm going to go into in detail here so you can exactly see what we mean by AI. And we're also using virtual simulation tools. This tire also has the EV root symbol, which I explained last night, which means it's compatible with EVs and gas vehicles. So AI. How are we using AI? This is how one press release clearly used AI to describe our AI process, and I can tell you it's nothing like this. It's not nearly as glamorous or cool-looking. Yeah, don't trust AI. What it really is far duller. But it all starts with the data we would collect on one tire. So for one tire, we have tire specification data, compound data, construction data, we know everything about that tire. We also have a ton of analysis data that we continuously generate using our FEA tools. So this is our virtual data. And then we have test data. All of our tires are tested in a multitude of tests. And all of this data we can link together. So this is all linked now. It's starting to form a database. And we have all of this linked data for 190,000 different tires that we've produced over the years. So you can now imagine the size of the database that we have, the data cloud that we have. And all of this we store on servers. And all of it is accessible to all of our tech centers around the world via a global kind of portal-based system. So I can access any of this data. Yeah, John, you got it?
I'm sorry, back up. You said 190,000 tires?
Yeah. 190,000 specs and sets of this data. That
different tires, not 190,000, 90,000 of them were an X and 100,000 of them were a Y. It's 190,000 different tires.
Different tires, but sometimes this could be like if we're developing for an OE, we're going to take one mold and we're going to do 4 versions of that tire. Different compounds, different constructions. That's all in this database.
Gotcha. Thank you.
Yep. Okay, so we can query this database. So what we have here is, so far, nothing very artificial intelligence-y, right? It's just a giant database. But because it's so giant, it's hard to use conventional tools. This is not something we can just use Excel or Microsoft Access to understand the size of this data. We need a lot of computing horsepower. So if you can imagine, we have this database full of test results and simulation results. With AI, we can start to take those design variables and do artificial intelligence, kind of machine learning on all of that data, and we can start to predict the tire performance. Because we have 190,000 data points that are correlated with tire performance, we can start to predict what's going to happen with such and such construction, or such and such mold change, or such and such compound change. We can take that data and we can do analysis on it and feed that back in. And we can also then do it the opposite way. Say we want to achieve a certain level of performance, we can go into this database and the database can tell us, oh, this is the optimal design to achieve that performance. So some of the tools we have, oh, by the way, this is called our virtual brain loop system in our pamphlet. So if you see virtual brain loop, that's what we're talking about. That's what I'm describing here. So this is, sorry, this looks dull, but this is an example of the tools that my team would use. So this is XAI. If you've seen XAI, this is explainable AI. we can enter design factors and ranges. So let's say in this case, we want to achieve, what do we got here? Rolling resistance and quartering stiffness. So we put in some target values, we put in some boundaries and data ranges. Okay, we want to look at steel belt angles from 23 to 33 degrees. We put in this information and AI is gonna feed back the factors with the highest influence. In this case, it's curing temperature. This is not something that I can pull out of this giant database myself. Okay, maybe if I wanted to do a study on curing temperature, I could go pull all that data out. I could spend days analyzing it, correlating it, but this is now happening in seconds. And that's really the AI technology that we're talking about. And it can also establish correlation. So this is that steel belt angle versus rolling resistance performance. So this is being pulled straight out of that database. So this is a fantastic tool for engineers to learn how to optimize the tire.
Yeah. So is that telling you what compounds to make?
It could. Well,
because earlier to John's, you said you might make 4 different types of tire, different compounds, and then test those.
yeah.
AI can't right now tell you, here's the formula to make that tire, and you don't have to do any of that testing?
That's the way it's going. Right now I can tell you which compound to use because that's in the database. But eventually, and we have some curing technology that tells us how to optimize cure, we're not yet to the point where it's going to tell you, okay, use 67 parts of this styrene vinyl polymer. But that's coming. That's definitely coming. It's all just a matter of this parameterization, getting all that data into the system, and then yeah, we can do that as well.
And then you can retire.
That's the fear, isn't it?
Is that a problem?
To be.
So this is the same process happening in the opposite direction. So I'm going to design a virtual tire over here. I'm going to put in all of the tire shape factors, the construction factors, the components, the compound information, and within a few seconds, what's going to pop out is a generic looking footprint, but it's going to be generally the correct shape, the rolling resistance values for that tire. In this case, we have some handling. These are force and moment values, which help the engineer. It's a bit hard to understand for the layperson. So we can quickly get the predicted performance, and then we can go in and we can start changing things little by little and instantly seeing the effect of those changes. Okay, we mentioned can AI predict the actual compound ingredients? Not yet. We are working on that, but not yet. This is our curing specification. So if the compound is like the cake batter, the curing process is like how long do we bake it for? What temperature do we bake it at? And how do we make sure that's all optimized? And these are all the variables that can go into that process. And then of course we can get outputs like optimal curing time and temperatures. So that's kind of an example of the way it's going. Another area where we're using AI, this is a little bit different, but you guys have noticed that AI can do image recognition now. There's Google image search, and there's a lot of visual tools. We're using that same kind of technology to pinpoint any potential manufacturing defects when the tires go through our X-ray process. So the tire has many quality checks as it's coming off the production line. There's uniformity checks, balance checks, and there's an X-ray check. And it produces images like this. And of course, we rely on an operator to go through and make sure there's no anomalies there. But now we have an extra layer of protection because through some of this AI-based image recognition, AI can can pull out that anomaly and make sure that it's caught. So it's just
From the X-ray?
Yeah, from the X-ray image. Yeah. So if we were to look at our design and manufacturing process linearly like this, which I will not explain, we have a team actually that's assigned to applying this AI-based machine learning big data approach across our whole process. And these are all the areas so far where we've applied some kind of AI or machine learning. So in cost prediction, the explainable AI in the design phase, along with the performance prediction software which I showed. This is the virtual piece, so we can design full virtual tires and analyze them in FEA. It's actually more precise than AI because we have the tire fully modeled. Every single component in that tire and every single property of every single component in that tire. And we can get very precise predictions of bone resistance, component force, footprint shape. So we have that. Compound performance prediction, so this is getting towards the recipe prediction, the cure spec prediction, which I showed, and the AI X-ray monitoring. So not very flashy, not like the image, but you can see all the areas where we're using this technology, and it will continue to grow. I mean, I think every industry is looking at these tools in the same way.